Hello there, and welcome to your first applied activity lecture. So today I'm really just trying to give you the information that you need to complete your applied activity for methods, but this is also going to be some information that'll lay the foundation for your ability to understand the research that we're going to be talking about and the journal articles that you're going to be reading this semester. So I'm going to start with a really very brief overview of IO psychology, industrial organizational psychology. If you want a more in-depth look into IO psychology and kind of what it's all about and the history of IO psychology, then read chapter 1 of your textbook. Then I'm going to spend most of my time on research methods and statistics. So just helping you understand the various terminology associated with the research methods in psychology and how research is conducted generally. And then really focusing on how to interpret and understand statistics because you're going to be, again, reading journal articles this semester. And I want to make sure that you are prepared to understand the most common types of statistics that you will be seeing. So let's first start with an overview of IO psychology. So I tend to think about things in terms of flow charts. So I'm going to draw a nice, pretty, maybe chaotic flow chart for you all right now. Now, it's important to notice that it's IO psychology, industrial organizational. And really, those are two somewhat separate fields of psychology. So the industrial side of psychology is more about human resource management types of things. And then the organizational part of psychology is more about studying the intricate relationships among employees and how that results in differences in performance and studying leadership and motivation and some more of those like psychological constructs that we see in other fields of psychology. So really the heart of IO psychology and the starting point for IO psychology is something called a job analysis. So we've got job analysis. So a job analysis is the process of gathering data and information to determine what types of tasks are associated with a job and what types of knowledge, skills, and abilities an employee needs to possess to do those jobs. So figuring out the tasks and the qualifications of a job. And we'll have a whole lecture about job analysis, but that's not for today. Now, the first thing that job analysis informs is recruitment. So once you know what types of employees you need, you can begin targeting recruitment to those employees that meet the qualifications. Then once you have recruitment, you need to select employees from the pool of candidates that you recruited. So employee selection. We'll have a whole lecture on employee selection as well, but basically that's just using tools to identify who will be the top performers so that you can make an offer and hire them. Now, there's a bunch of different ways to do employee selection. Resumes, interviews, references, testing, whatever makes sense for your organization. Then once you select employees, you need to train them. So training is also an area relevant to IO psychology. So figuring out based on the job analysis what types of tasks are involved in the job and determining what knowledge, skills, and abilities employees need to be trained to develop. Then once you have trained employees, you're hoping that that will result in high levels of performance. So IO psychologists also have ways to measure performance. And I'm going to add a little double-sided arrow here because training leads to performance, but deficits in performance can also lead to training. So that arrow goes both ways. Performance ultimately leads to organizational effectiveness. We're going to abbreviate org effectiveness. Now, I'm never going to quiz you on this beautiful picture. I'm just trying to help you understand all the connectedness between the topics we're talking about this semester. Performance also can lead to financial incentives and benefits. So getting bonuses, that sort of thing. And those financial incentives and benefits can lead back to performance, right? So they can motivate employees to perform better. Now, it's also important to note that job analysis also dictates job evaluation, which is determining the worth of a job. So how much people should be compensated for their work. And that job evaluation also leads to which types of financial incentives and benefits employees are offered. So this is the industrial side of psychology. The organizational side of psychology is also concerned with performance, but again, it's more about the experiences of the employees, not necessarily the policies and procedures that affect employees. So when we look at the organizational side of IO psychology, which is the part I find most interesting, not even going to lie. Again, we are looking at performance, right? Because that still matters in organizational psychology. A lot of times the way that employees think and feel and experience their work have an impact on performance. And so some of those things that impact performance would be like organizational culture and climate. So, how employees feel about each other, how they feel about the organization, how they're treated, what the values are of the organization. Also, leadership is huge. I'm sure many of us have had terrible bosses that made us not want to do our job, or really good bosses that motivated us to perform. Which also, so the culture can lead to leadership, right? And the leadership can lead to the culture. Leadership also, again, can lead to motivation of employees, employee attitudes, how they feel, and employee perceptions, what they think, which in turn leads to performance. Also, that motivation, attitudes, behavior, or motivation, attitudes, and perceptions can also lead to different behaviors on the job, like organizational citizenship behaviors, group relations. Happy employees tend to work better together, and well-being of employees, which is also studied by IO psychologists. We don't just care about performance, but we also care about the health and well-being of the employees that we're studying. Now, it's important to notice the crossover here too. Financial incentives and benefits can also lead to motivation, attitudes, and perceptions, right? So it's important to see kind of the crossover there. So that is a very extensive and kind of big picture of industrial organizational psychology and the different types of topics that will be coming up throughout the semester. So all of these processes require research to monitor their effectiveness and develop new ideas. So effective organizations, and usually bigger organizations, not necessarily tiny small businesses, but the bigger organizations are constantly researching the effectiveness of these practices and tweaking it as they go. IO psychologists are the people that are typically doing such research. So HR staff typically work in like a narrow area of industrial psychology using tools developed by IO psychologists. So there's very much a relationship between industrial organizational psychology and human resource management, but the IO psychologists are people that are doing the research, developing the tools, and assessing the effectiveness of the practices that are enacted by the human resource staff. Okay, into research methods. Now, again, this is covered in the textbook, but I want to get more in depth about a couple of these things that are relevant to your applied activity and all the things we're going to be doing this semester. So I'm not going to give you the complete and total overview because it's in the textbook. I'm just going to hit the highlights here. All right, so in general, a population refers to all people, places, or things of interest. So all In this case, we'll say people, because it's a psychology class, of interest. Okay, so as an IO psychologist, typically I am interested in all employees or maybe employees at of a specific profession. So let's say that I'm interested in studying college professors. That is what I want my research to apply to, is all college professors. But chances are I'm not going to be able to do a study with all college professors. So I take a sample or a subset of the population that I actually study, that is studied and hopefully represent the population. That's a big hopefully. So an example would be NSC, Nevada State College professors. That's who I have access to, so I'm going to study them. I actually just finished up an organizational climate survey, and I was the lead on that effort, where I measured a ton of different variables about the work environment among NSC professors, and I plan to publish a journal article or two and do some conference presentations about my findings. And when I'm talking about my findings, I'm not going to just say professors at NSC. I'm going to say, based on these findings, I think that professors in general have these things going on. And I'll show you a couple snippets from the climate survey here in a little bit as well, because it's pretty interesting stuff and it's super relevant. All right, so there's different types of samples. So the gold standard is a random sample, okay? So a random sample is where everybody has an equal chance of being selected. And when you're doing that, you're trying to control for individual differences. So that helps you kind of assume that if you're randomly selecting from the population, all those weird things that make us all unique and different will be represented in your sample if it's large enough. So controls for individual differences is the hope. And it's expected to resemble the population or represent the population. Now, think about my example above, right? If I want to study all college professors, so I take a sample of, a random sample even, of Nevada State College professors, how representative will that be of the population? Not very, right? It's not a random sample. It's a very specific sample. So we're not going to probably be controlling for those individual differences. We don't necessarily expect NSC professors to represent all college professors because NSC is so unique and amazing and fantastic. Okay, now there's another type of random sample that I really like called stratified random sample. All right. So a stratified random sample is when you randomly sample within subgroups to ensure representation. So you randomly sample within subgroups. And I will post these slides for you, so don't feel like you have to feverishly write all this stuff down. On your notes page, it's probably best if you just take notes in your own words, and then you'll have these later. Okay, so stratified random sample, randomly sample within subgroups to ensure representation. So I'll explain what that means. So when you take a random sample, everybody has an equal chance of selection. Now, that could be problematic if there are groups that you're interested in that aren't very large within your population, because you may miss them in your random sample. So in a stratified random sample, you randomly sample from those specific groups. So let's say that among NSC students, and this is actually based on current data, 34% of students are white, 30% are Hispanic, 11% are Asian, 10% are Black, and so on. So what you would want to do is you would randomly sample from the white students, and you would take 34% of your sample would come from the white students. So you'd take all the, like let's say that you had a sample of 100. So n is what sample size, n equals 100. Well, then 34 of the people in your sample should be randomly selected white students. And again, 30% Hispanic. So if you had a sample of 100, you would randomly select 30 Hispanic students to be in your sample. So at the end of the day, you have maximized the ability of your sample to represent the population, and you've made sure that you haven't missed any important small groups. I love me some stratified random sampling. So another one I want to talk about, so we've got random, stratified random, convenience. So it's hard to write and spell and talk at the same time. There we go. Convenience sample is basically studying whoever is available, right? So you're thinking about like volunteers, who we have access to. Now, my sample in my example above is a convenience sample. I want to study all professors. I don't have access to them. I'm going to study NSC professors. Now, the problem with that is that typically convenience samples do not represent the population. Because people that volunteer for a study may be unique to those who do not. And if you think about it, oftentimes you start off with a random sample and then it turns into a convenience sample, especially with human subjects research. Because I could, let's say I'm trying to do a survey with students. So I randomly select 34 white students and 30 Hispanic students. Well, they still can choose not to take the survey, right? So then that beautiful random sample turns into a convenience sample of people who are actually willing to participate in your research. So now that we have touched on populations versus samples, let's look at hypotheses, all right? So it's important to note that a hypothesis is a specific, educated guess. Underline educated. Based on past research. Okay? So this stating a hypothesis requires a review of the literature on the topic that you're studying. So to join the conversation, you must figure out what they are talking about. So you can't just state a hypothesis from your brain without any previous knowledge of research that's already been done relevant to the variables that you're making a hypothesis about. You should also state a hypothesis before the study is designed. So you want to state the hypothesis before data collection, or at least before data analysis. You don't want to just collect some things that seem interesting and then start trying to find hypotheses that work after the fact, because you're going to get very frustrated with the fact that maybe you didn't collect some things that the research says are important, and really you're not supposed to run an analysis and then go, oh yeah, I knew that was going to happen. That's bad science. Okay, also you have to make sure that hypotheses are testable. Okay, so making sure that at the end of the day, you're actually going to be able to study what you want to study. So an example I use in my advanced research methods class is that let's say that you're trying to do a study to see which type of fruit monkeys prefer in a lab setting. So a testable hypothesis would be monkeys prefer bananas, right? But something that wouldn't be testable would be monkeys prefer bananas in the wild because they're easier to get to. You can't test how easy it is to get to, and you can't ask the monkeys how easy it is to get to. So that's not a testable hypothesis. Okay, now it's important to note what hypotheses are not. So hypotheses are not the same as research questions or ideas. So a research question is a question about an observation, but it's not specific, right? So not research questions because they are not specific enough. You have to make a specific prediction with a hypothesis. A research question is like, will this happen? Will monkeys have a preference in food? Well, that's not a testable hypothesis. That's more of a research question. We don't know. We're going to find out. Hypotheses are also not theories. A theory is a widely accepted explanation that's well tested through replication. So, theories are developed after testing many hypotheses through replication that come out the same way. Okay? So a theory tends to explain hypotheses. So a lot of times when you're stating hypothesis, it's going to be based on previous theory. So theories inform hypotheses. Okay? So if we look up here, you'll see an idea or a research question. It seems people don't work as hard in a group as when they are alone. Well, a hypothesis would be, specifically when pulling on a rope, a person working by themselves will exert more force than a person working in a group. That is testable and it's specific, and it's based on past research on social loafing, which is a theory that suggests that people don't work as hard when they're in groups. All right, now it's time to get into specific types of research methodology. So there's three major types: true experiment, quasi-experiment, and correlational. So let's start with a true experiment. So the true experiments are kind of the gold standard because true experiments are the only way to make causal inference or to say one thing caused another. So a true experiment is the only way that you can say X causes Y. And even with a true experiment, you should replicate your findings to make sure that X actually does cause Y. So a true experiment has three different criteria. So in order to be a true experiment, you have to have randomization, and I'll explain each of these in just a sec, manipulation, and control. So randomization doesn't necessarily mean random selection, although that would be nice if you had a random sample. Randomization means that people in the study are randomly assigned to different conditions or groups. So random assignment to groups. Okay? Manipulation means that the researcher actually manipulates something in the study. There's some sort of intervention or some sort of treatment or something that's actually done to the participants. Okay? So something is changed or delivered to them in some way. Then control means that everything other than the manipulation is the same for all the groups. So you keep things consistent. So for instance, let's say that I want to do a true experiment where I'm going to try to see if public shaming or financial incentives are more of a motivator for professors to be a better teacher. And so I randomly assign half of my group to be in the pie in the face at the end of the semester group. So let's say if they get terrible course evaluation ratings, or let's say their students don't like them, then they get to have a pie thrown on their face at graduation. The poor professor, public humiliation. Another random half of my professor group will be assigned to the financial incentive group. So if they do well, they have high course evaluations, then they can get a 2% bonus. Okay? Manipulation is the type of incentive, right? Financial incentive or the fear of public humiliation. And then for the control, I should make sure that the professors in both groups are teaching similar classes, are at a similar level, so have been here for a similar amount of time. Make sure that you just control for anything else that could lead to differences in teaching other than the fear of public humiliation or the financial incentive. Now let's talk a little bit about a quasi-experiments. Quasi-experiment. Okay. So a quasi-experiment is something that involves no randomization, but could still have manipulation. Not always, but could. So something's manipulated in the study. And the common types are longitudinal designs or pre and post test. Basically, a pre-test, post-test, you measure the outcome that you're interested in, or the dependent variable, which we're going to talk about in a minute. So you measure the dependent variable, then you manipulate something, and you measure the dependent variable again. So let's say that I decide that a pie in the face is too severe. So instead, I am going to take and just look at financial incentives. So let's say that in the spring semester, there is no financial incentive. And then in the fall semester, I tell professors that if you get really high course evaluation ratings, you're going to get a 2% raise. So we look at their course evaluations before and after they were told they could get that financial incentive. You could also rely on pre-existing groups. So let's say that I thought that professors in psychology have better course evaluations than professors in some other group. I don't want to pick on anybody, so I'm not even going to say it. That would be comparing two different groups of professors. They weren't randomly assigned. They already existed, and we're just looking at differences. Then finally, the weakest type of research methodology and the most commonly used is correlational research. Okay, so that is where there's no randomization, manipulation, or control. You're really just seeing how naturally occurring variables are related in a single group. So natural observation. Nothing is manipulated. No groups are compared. Now, correlation research is very common in IO psychology because it's difficult to go into an organization and start manipulating conditions. We do a lot of lab research where we artificially manipulate conditions in a lab, but that research doesn't always directly translate to the reality of the workplace. So, for instance, if I wanted to study job insecurity, I could not do a true experiment in an organization, right? I couldn't go into an organization and randomly assign groups of employees to be told that their job was at risk, right? That's not ethical, and I don't think any organization is going to let me come in and play around with their employees that way. But I could have a lab study where students come into a lab, I guess, at a college, and I give them a job task, and I tell them that if they do a good job, then they will get to come back, and if they don't do a good job, they don't get to come back. And then another group, I could tell them they get to come back no matter what, right? So I could manipulate job insecurity to see if it has an effect on performance in that way. But it's problematic, right? The way that students behave in a lab setting may not be the same as if somebody actually is on the job and they're making money on the job to pay for their kids' food, right? It's a very different type of scenario. All right. So now let's get into the difference between independent variables and dependent variables. So an independent variable is really the predictor in a relationship. So it's the predictor. Okay? It's the thing that is manipulated in an experiment. So it would be like the financial incentive versus the pie in the face, right? The type of incentive would be an independent variable. and it is the groups compared in a quasi-experiment. So if I was comparing professors from different fields, then field would be the independent variable, and then we would look at the different groups. It's also, in a correlational study, it is the variable that comes first. So I'll tell you what that means in a second. So variable that comes first in correlation. So an example of this would be basically there's this strong debate in IO psychology about the relationship between performance and job satisfaction. Some people think that because there's always a really high strong relationship, right? Those who are better performers tend to be more satisfied. But is it performance that's leading to satisfaction, or is it the people that are more satisfied tend to perform more because they're happier, right? So that's the problem with correlational research. You don't always know which one is the IV or the independent variable and which one's the dependent variable. You don't know which one necessarily comes first. But based on past research, you usually make an assumption about which one is the independent variable and which one comes first. And typically, we think that performance is the outcome of job satisfaction. And job satisfaction is usually treated as the independent variable in that relationship. So independent variables are the predictor that lead to what we actually measure, the outcome of interest, dependent variables. So let's take a look at those for a sec. So dependent variables are the outcome, the thing that you want to change as a result of your study, or the thing that you think happens as a result of the independent variable. So we can think about the dependent variable as the measured impact of a manipulated condition or pre-existing group. So it has to be measured. Okay, so the measured impact of a manipulated condition or a pre-existing group. Now, dependent variables can be truly numeric. So they can be an actual number. So for instance, like sales, right? That's a clear-cut number. Number of times late to work, right? Those sorts of things are clearly numeric already. But sometimes DVs are non-numeric. And in order to test hypotheses with statistics, you have to measure quantitatively or operationalize your dependent variables. So if you have a non-numeric dependent variable, then you can use a Likert scale to make it numeric. So, for instance, like course evaluations that you guys complete at the end of the semester, we can't just say, how happy are you with your class? And you give us a number. It's not a truly numeric thing. So we ask very, very specific questions and have you rate on a scale from 1, not at all, to 5, like highly satisfied. Also, you can see here with the teamwork scale from the organizational climate survey that I conducted at Nevada State College, instead of just asking people, do you feel like you have teamwork? That's not something we can analyze. And if we tried to assign just a number to it, it really wouldn't be that effective because everybody has a different perception of what teamwork is. So we can't say, oh, how do you feel about your teamwork and analyze it. We also can't say, rate your level of teamwork on a scale of 1 to 7. Instead, we have to ask very specific items about teamwork. So when we think about teamwork, we can think about a whole host of different things. But if we ask specifically, communication between departments is good. That is an aspect of teamwork. It's very specific. Everybody who's reading that item is probably going to be thinking the same thing. So in research, we typically ask several items to tap into one construct or one variable. And then at the end, we create an average of all these items for each person, and that's what gets used in the analysis. So for instance, let's say that I was completing this survey and I responded 7s and 6s to all of these. Well, then my mean scale score would be about, a 6.5 across all these items, and that's what would be plugged into the analysis. All right, so let's kind of think about some example hypotheses and then identify the IV and the DV. So let's see. Hypothesis. From the example earlier, could be people in groups don't work as hard as people work alone, right? So people in groups do not work as hard as people who are solo. And we could even say people in larger groups. Okay, so for this hypothesis, we could do a study, even a true experiment, where we randomly assign people to 3 different conditions based on group size. So that's what we're manipulating. That's our independent variable. And we could say we have 3 different levels, right? Alone, small group, and large group. And we could have them play tug of war and see how much effort they exert, which would be our dependent variable. And that would be like the level of force in tug of war. And we could measure that through a force gauge, which gives us a nice numeric measure. Here's another example. Hypothesis. So let's say if we're doing a correlational study, we want to think about teamwork. Professors who have more supportive supervisors also have more teamwork. Okay? So in this case, we're not manipulating anything. We're doing a correlational study. And in correlational research, we don't just measure the dependent variable. We also measure the independent variable. So we would have kind of a quasi-IV, right? Quasi-independent variable, either pre-existing groups or things that you measured, of teamwork, or I'm sorry, of supervisor support. And in this example, our dependent variable would be teamwork because we think that supervisor support comes first. And those with supportive supervisors tend to also work better with their team. And you can make the case it goes the other way around, right? If you have a really cohesive team, maybe the supervisor feels more supportive, but research probably suggests the supervisor support comes first. So I hope the examples help you make sense of all of this stuff. Okay, if you need a break, now may be the time to take a little break. Maybe go potty. I say potty because I have kids. Eat a snack because we are about to jump into statistics. And I'm going to just give you the bare essentials. I'm going to try really hard not to get too deep because I am a statistics professor too, but just give you what you need to understand the applied activity and journal articles as we move forward. So if you need to take a break, go ahead and come back. If not, let's move on to statistics. Here we go. So there's 2 different major fields of statistics, descriptive and inferential statistics. So first I'm going to focus on descriptive statistics, which are just meant to describe the nature of the trends in your data. So if we start with the mean is just a fancy stats word for the average. Okay? And the mean is equal to the sum of all scores, so add all the scores together, and divide by the number of scores. Again, it's just the average. And a mean has different notation. You may see for a sample mean, you might see it look like just an M or an X bar. And then if we're talking about a population mean for everybody, then you'll see a symbol like mu. Okay, the mode, well, let's do median. Median simply is the midpoint. So 50% are at or above that score, and 50% are at or below whatever the median is. Then the mode equals the most frequent or common score. So I'm going to embarrass myself. There's a really silly song that a couple of my students taught me that they actually learned in high school about this to help you remember the different measures of central tendency. Let's see if I can do it justice. All right. Mode's the most. Average is the mean. Median. Median's in between. All right, that's enough of that. Okay, so now let's move on to variability, or the main measure of variability that we care about in statistics is the standard deviation. All right. So standard you can think is another word for typical or like common. Deviation is like a word for differences. Okay? So the standard deviation tells you the typical difference between scores and the mean. So how spread out or how far away most scores are from the mean. If you have a higher standard deviation, that means that scores are more spread out, less consistent. More spread, less consistent. If you have a lower standard deviation, well, that means the opposite, right? Scores are less spread out and more consistent. So, for example, and because the mean is the reference point for the standard deviation, in this example, I'm going to ignore the median and the mode. Let's say that you have a quiz, and it's a 100-point quiz, 100%, right? Let's say that the mean quiz grade was an 80%, and let's say that the standard deviation, which could also be abbreviated for a sample, let me put that here. So for a sample, it's usually an S. For a population, it's usually sigma, or you may just see straight up SD. So with a quiz with a mean of 80 and a standard deviation of 10, most students scored between 80 minus 10, 70, and 80 plus 10, 90. So most students scored between a 70 and a 90. Most students are within 10 points of 80, within one standard deviation of the mean. So most students scored between 70 and 90. So that's how to use the mean and the standard deviation to understand the trends in data. All right, now let's look at inferential statistics. So inferential statistics is not just explaining the trends of data in your sample, but taking what you found in the sample and seeing if you can make inferences about the population based on it. So if we find that public shaming is more powerful predictor of teaching performance than financial incentives, then maybe we should start public shaming our professors, right? And it's not enough just to say that there is a difference or that the public shame group was higher, but there has to be a significant difference. Okay, so that's what p-values get at. So let's go ahead real quick, and I'm just going to break down statistical significance, and then we'll talk about p-values. So statistical significance. You hear that a lot, right? There was a significant relationship between blah and blah, or those who received this medicine had significantly better outcomes, or whatever. So let's figure out what the heck significance means. So if findings are significant, that means several things. It means that the findings are not likely due to chance or randomness. We can be confident that the IV actually had an effect on the DV, and we can be confident that similar results from our study would be found in the population. Because it's not a fluke. We are confident we got the results because whatever we manipulated worked. All right? Now, p-values tell you about the significance. Okay? So how confident are you in your findings? So a p-value tells you the probability that results are due to chance or error, specifically sampling error or a fluke. Okay? So in statistics, we really like low p-values, okay? Low p-values mean there's a low probability that results are due to chance. So specifically, if we have a p-value that's less than 0.05, that means there's a less than 5% chance, 0.05, 5%, that results in the study are due to error. So then we would call that a statistically significant finding. Okay? Now let's think about differences between groups versus relationships among variables. So there's different types of research. Typically in the experimental or the quasi-experimental, we're looking at differences between groups. And two of the most common analyses for looking at differences between groups is a t-test, when you have two groups to compare, so like pie in the face versus financial incentive, or an ANOVA, analysis of variance, when you have two or more groups. So if I had a financial incentive group, a pie in the face group, and maybe a control group that had no incentive whatsoever, right? I'd have three groups, I could run an ANOVA. Now, when we look at relationships among variables, typically we are talking about correlation, which is what I'm going to focus on in a minute, and also regression, which is when you take a correlation or a relationship between variables and use it to make predictions. So let's take a look at a t-test, and this is actually pulled from the Nevada State College Organizational Climate Survey Feedback Report that is 100 pages that I made. So if we look at this table here, we can see, let me see if I can make it a little bit bigger. Scoot this guy over just a bit. Here we go. All right. So the way this table works, we've got liberal arts and sciences full-time faculty here and part-time instructors here. You'll see that each of the variables that I measured for the workplace stressors portion of the survey are here. So lack of space, lack of policies, discrimination, all those things. And you'll also see the means and the standard deviations are presented here. And if you look at the text at the bottom of the table, so it's saying work overload is based on blah, 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 blah. Okay, the largest group mean for each construct is underlined. So that's where the underlines come from. Variables with significant alpha equals 0.05 differences are bold. So alpha means the criteria for the p-value. So if my alpha is 0.05, then again, that means I have to have a p-value less than 0.05 to call it significant. Or in other words, all of these bolded variables mean that there is a meaningful, reliable difference in that variable between these two groups, and that I think those differences extend beyond who participated in the survey. So for instance, because there's a significantly higher level of stress due to lack of space among full-time academic faculty, I think that all full-time academic faculty in LIS in general feel like there's more of a lack of space than the part-time instructors. So remember, the mean is the average, right? Overall. And the standard deviation tells you how spread out the scores are. So if I ask you which type of stressor had the most consistent ratings for full-time LAS faculty, you should be looking in the standard deviation column for full-time faculty. So if we're looking here, most consistent means the lowest standard deviation, right? Less spread of scores means more consistent. So if I look here, I will find that the lowest standard deviation is for difficulty with transportation. So that would be my answer to that question. And really, it looks like there's consistently low scores because this is really low. All right, so I want you to try the next one. So pause the video and figure out by looking at the table which type of stressor had the least consistent ratings for LIS full-time faculty, and you're still looking here. Okay, so hopefully you pause it and tried it on your own because testing yourself is the best way to learn. So if we're saying the least consistent ratings, another way to think about that is saying which have the highest standard deviation, the most disagreement, the most spread in scores. So in this case, that would be inadequate training for supervisors and then there's also a 2 for conflicting job demands. So among full-time faculty in LAS, there's a lot of disagreement in how well supervisors are trained and how much job demands conflict with each other. There's a lot of disagreement. If you think about what we demonstrated earlier, right, most quiz scores are between these two. Well, in this case, most people that responded to this survey have, if we take the standard deviation and subtract it from the mean and then add it to the mean. So most people rated themselves between around a 0.8 for the mean of that, all the way to a 4.8. So that's a huge range. There's a lot of disagreement there. Now let's think about which type of stressor had the highest overall ratings for LAS full-time faculty. When we talk about overall, we're talking about the mean. So we would need to figure out which one has the highest mean. And I can attest to this, work overload. So work overload is by far the most felt stressor among full-time faculty in liberal arts and sciences. So now you take a shot at figuring out which type of stressor had the lowest overall ratings for full-time faculty in LAS. So pause the video and give it a try. Okay, so hopefully you tried it on your own. And now if we look at this, now we're looking for the lowest means overall. And if we look here, thank goodness, sexual harassment has a really low mean. And also difficulty finding reliable transportation. So those are stressors that aren't really affecting my work group as much. So I hope that looking at a table like this will help prepare you for looking at tables and journal articles and figuring out what this all means, and you'll get some practice with this on the applied activity. So here's an example of an ANOVA table, because this one, t-test, 2 groups. Well, if we're comparing all the different schools together, well, then we need to use an ANOVA because we're looking at more than 2 different groups. And you can see here the table is outlined the same way. There's definitely differences, right? You can see that. Libraries tend to be really happy because now we're not looking at stress, we're looking at happy stuff. So the folks in the library have really high ratings for all the good things. And even though there are differences, right, we can clearly see that supervisory support is higher in the School of Education than it is in liberal arts and sciences, but there's not a significant difference there, right? It's not reliable. We're not confident that that difference exceeds what we would expect to see just due to random chance. But when we look at the number of students in classes, the School of Ed is clearly significantly happier about the number of students in their classes than those in the School of Nursing. And with ANOVAs, just because it's significant doesn't mean these are all different. When you actually dig into the data more, you see there's only a significant difference between the School of Ed and School of Nursing. There isn't a significant difference between the School of Ed and Liberal Arts and Sciences. So I'm going to put a little note here. A significant ANOVA only tells you that at least two groups have significant differences. You have to look at the nitty-gritty of the findings that will be explained in the article to figure out specifically which groups are significantly different. So at least two groups have a significant difference. Not necessarily all of them, but it could be. All right, we're almost there, you guys. Okay, so now let's think about correlation. Correlation analyses are really common. So there's a couple different aspects of correlation that you need to think about. I'm never going to ask you to run a correlation analysis, but you need to be able to look at correlation values and understand what they mean. So there's two different aspects of correlation. One is direction, and that is told to you by the sign of the correlation. So you'll see over here, we have negatives, negative 0.74, and positives, right, 0.68. So when it comes to direction, a correlation that is positive means that variables tend to change in the same direction, okay? So higher levels of X tend to be related to higher levels of Y, and lower levels of X tend to be related to lower levels of Y. So variables tend to change in the same direction. So some examples of that would be number of young children in stress. I have 2 young children, I'm pretty stressed out. So more young children, more stress. Fewer young children, lower stress. That's a positive relationship because they're changing in the same direction. Another example would be like burnout and turnover intentions. So employees who are more burnt out tend to want to leave the job more. And you can actually see that here, right? So exhaustion and cynicism are both aspects of burnout. So employees who, oh yeah, here it is. That's convenient. Higher levels of exhaustion and cynicism tend to report stronger intentions to quit, right? Same direction. More cynicism, more likely to quit. Okay, negative relationships is an inverse relationship. So higher scores on X tend to be related to lower scores on Y, and lower scores on X tend to be related to higher scores on Y. So opposite direction. So an example could be sense of belonging and turnover intentions, or perceived organizational worth and turnover intentions. If we look at part-time instructors in LAS, check this out. So those who feel more perceived organizational worth, they feel like they belong, are less intent on quitting. It's going in the opposite direction. Let's see. Another one would be like sleep and stress. If you sleep more, you're probably less stressed out. If you sleep less, you're probably more stressed out. Those sorts of things. Okay, so opposite direction versus same direction. You'll also notice, just to point out real quick, in this table, see the little stars? So a lot of times in tables that you'll see in journal articles, there will be these little stars. And if you see a star, that means that you have a significant finding. So 1 star means there's less than a 5% chance that results are a fluke. 2 stars means there's less than a 1% chance that results are a fluke. So we're even more confident in our results with 2 stars than we are with our results with 1 star. All right, the next aspect of correlation is strength. Okay, and that is the number, the numeric value. So correlations range in strength from -1 to 0 to positive 1. So if you have a correlation around a 1 or a negative 1, that is the strongest relationship you can have. It's very consistent, okay? But the closest that you get to 0, the weaker the relationship is, okay? So if you have a correlation of negative 0.74, right? That's right around here. That is a strong negative relationship. So consistently, those who feel more perceived organizational worth tend to be less intent on quitting, okay? The weakest relationship that I have up here is this negative 0.41, and that would be like right around here-ish, right? It's still a pretty strong relationship, but it's weaker than the original, the negative 0.74, okay? So the closer to 1 or negative 1, the stronger the relationship, the more consistent the relationship. And the closer to 0, the less consistent or the weaker the relationship. Now, regression allows you to make predictions. So I could predict how likely someone is to quit based on either one or all of these things added together. So you can make predictions, and you can examine multiple quasi-independent variables to see which has the strongest relationship. Oh my goodness. After controlling for, oh my goodness, co-occurrence of variables. So let me explain that. You won't do this on your applied activity, but you may see some regression in the journal articles you're reading this semester. So if I plugged all of these variables in at the same time as predictors, because each one of these, this is just looking at the relationship between these two in a vacuum, not looking at anything else. Well, chances are that these things, all these variables are related. So if you plug them all into a regression, you could look at the relationship between perceived organizational worth and quitting intentions while controlling for the fact that perceived organizational worth is also related to all these different things. And then you can see which predictors pan out in that way. Also, I want to point out, you're never going to run these analyses, so if you're freaking out, stop it. It's going to be okay. And in journal articles, you don't necessarily have to be able to look at the tables and know what they mean, because there's always sections in journal articles that explain the results in words. And I am going to give you guys a guide to reading journal articles to help you with that as well, because I know that that's not something that all of you have done before. So I hope that this lecture helped you understand methods and stats. I hope you have a good time doing your applied activity, and feel free to go back and watch this video if you're reading journal articles and you're struggling.